Hello, this is a lecture on time response of first order system. Okay, we'll see the question first. The question is, find the time response of first order system under unit step input. Unit step. This is a question. So what we supposed to find? C of t. C is output, time response is C of t. And here the input he has given specific input, he has mentioned R of s equal to 1 by s. It is called what? In the previous lecture we have seen. This is called unit step input. Given. This is given in the problem. And first order, we know the standard form of first order transfer function. We know standard form of first order transfer function. T equal to time constant. Time constant in seconds. In the RC circuit, T equal to RC, or in the water tank system, already I saw there is AR. T is a constant. Now I want to find C of t. So what I'll do, the given input, I have to substitute the given input. Here R of C of s equal to 1 by s, that is 1 by Ts plus 1. So C of s equal to 1 by s Ts plus 1. Okay, fine. Now what is the C of s? What is the C of s now? C of s equal to 1 by s Ts plus 1. What I want? I want C of t. Inverse Laplace. I will take inverse Laplace. But before taking inverse Laplace, it should be to convert multiplication factor into addition factor. That is called partial fraction. There are three formulas for partial fraction. We know three formulas. For example, x plus 2, x plus 3. Then a by x plus b by x plus 2 plus c by x plus 3. First formula. Suppose 3 by x into bracket x plus 2 whole square. Here also 3 constant because highest power of x is 3. But here b by x plus 2 and c by x plus 2 whole square. And suppose 3x square plus 2, here also the highest power of x is 3, so that 3 constants, but this is a third method of writing the partial fraction. There are three formulas. So here definitely I will apply the first formula, that is what? 1 by s Ts plus 1. The highest power of s is 2, means what? Two constants are required, a and b. A plus b by Ts plus 1. Now I will take a LCM, Ts plus 1. Here also s, Ts plus 1. And here 1, here Ts plus 1. Here s, 1, a into bracket Ts plus 1 plus Bs. This is get cancelled. So 1 ATS plus A plus Bs. So I will take AT plus B, S plus A. Here I can write 0 S plus 1 because here no S term. I can write 0 S. Why? Because next is to find A and B value by comparing coefficients. Now comparing coefficients, first compare the constant A equal to 1. Correct? Then you compare a S coefficient. AT plus B equal to 0. Already A equal to 1. T plus B, then B equal to what? Minus T. I have got both the values of A and B. Now I will substitute A and B, then I will take an inverse Laplace. Now the C of S equal to A is nothing but 1 by S plus B is nothing but minus T, Ts plus 1. But here you see the Laplace, some modification is required because you know that Laplace of e raised to minus at equal to 1 by s plus a. Laplace inverse of 1 by s plus a equal to e raised to minus at. Here s coefficient is 1. But here there is a t, so that to make s coefficient is 1, what we have to do? We have to divide the capital T, numerator as well as denominator, by capital T. So C of s equal to 1 by s minus 1 by s plus 1 by t. Because to take a Laplace inverse of 1 by s plus e. Now taking a Laplace inverse of C of s, Laplace inverse of 1 by s, Laplace inverse of 1 by s plus t. We know that Laplace of 1 is 1 by s and Laplace inverse of 1 by s is what? 1. So here C of s becomes C of t. The Laplace inverse of 1 by s is 1 minus e raised to a is nothing but 1 by t minus a into t. Small t is a time, capital T is a time constant. What is this? This is called time response of a first order system. Under time response of a first order system under unit step input. Unit step input. Whenever there is a unit step input, this is the response output. So now we will draw a graph for this response C of t. So if I draw a C of t graph, you know that this graph is what? For example, e raised to ax, suppose this is a y and x, and this is called e raised to minus ax, suppose if it is a y and x, but it is a 1 minus something is there, so that the graph will be different. First I will draw the input r of t, that is r of t equal to how much? R of s equal to 1 by s, unit step input. It starts from 0. The time you have to draw a C of t curve. So how to do? You substitute, is it the output C of t curve is passing through origin or not? You put t equal to 0, then C of t equal to what? 1 minus e raised to 0, that is 1 minus 1, that is 0, it is passing through origin. You put t equal to infinity, C of t equal to 1, e raised to minus infinity, that is 1 minus infinity, that is 1 by 0, that is 1. C of t is 1. Now it is different from these two, means when the time sufficient t is equal to infinity, means after sufficient time the output is 1 because input is 1. So that this is your response curve. This is your C of t curve. But when it comes to the 1, after that the output is remains same. So this is called what? I'll divide into two phases. The first phase, when the output goes on changing, that is called transient phase. When the output is constant, it may be 0.9999 or it may be 1.001 or it may be 1. The output will stabilize, the output is constant, that is called steady state phase. In the control system there are two phases, transient phase and steady state phase. Okay, transient phase may be 2 seconds, 3 seconds, 4 seconds or a 60 seconds. Fine. Or it may be in the classroom, as soon as when the professor will come, the transient phase is 5 minutes because he has stood up the board and students will take a second notebook, next notebook, and they have to switch over from the previous lecture to a new lecture. So transient phase may be 5 minutes or 6 minutes. For you take any system, Computer, if you start a computer, the immediately computer will not start. It will take 1 minute or a 2 minute. That is called a transient phase. Okay. Now here one more thing, I will talk about a steady state error or a error. You see here error is nothing but, I will put a heading, steady state error analysis. Steady state error analysis. So here the error is equal to what? The difference of input to the output. This output curve. So R of t minus C of t. But I am not interested in error because I know that error is initially beginning high, then the error goes on decreasing. But what about the final error? As soon as I will give the paper to you for a 3 hours exam, after 10 minutes if I see, because you are attempted only 5 marks. But I have to worry after 3 hours how much you are attempted. Are you attempted out of out? Then error is 0. If you are attempted 90%, the error will be 10%. That is called a steady state error. Means error after sufficient time. So in the mathematics, steady state error, ESS, steady state error, I will call ESS. Steady state error, limit tends to infinity after sufficient time of the error at any time. That is equal to limit S tends to t tends to infinity, that is R of t minus C of t. It is in the time domain, but in the control system everything I am solving in S plane. So steady state error, when S becomes 0, then multiply by S, because t becomes S, infinity becomes 0, then multiply by S, the R of S minus C of S. This is called a steady state error formula. Because I know R of S, I know C of S, I will find a steady state error in this case. Okay. So here I will find a steady error may be 0, error may be some plus value, or error may be infinity also. Now in this case, how much is the steady state error? I know R of S in this case, the unit step input, and C of S before partial fraction. I know the C of S value also before partial fraction. Just you refer. And I know steady state error equal to limit S tends to 0, S R of S minus C of S. Limit S tends to 0, yes, what is the R of S? 1 by S. What is the C of S? S t plus 1. Only in the limit, you should not get 0 by 0 or infinity by infinity, because it is an indeterminate. Whenever you will get a 0 by 0 or infinity by infinity, there is no need to apply the L'Hospital rule, but only you take a common or remove the bracket and something. So here, limit S tends to 0, I will take a LCM first. LCM is S Ts plus 1. Here Ts plus 1, here 1. So Ts plus 1 minus 1 get cancelled. And here, yes, this is get cancelled. So Ts divided by Ts plus 1. Now if I put the limit 0 divided by 0 plus 1, that is 0 by 1, that is equal to 0. Means what? What is the conclusion? What is the inference? Whenever there is a unit step input for a first order system, that is very important. The steady state error will be 0, means whatever you are giving an input, the output is showing. Suppose the pressure gauge, if it is a first order system, if the mass of the pressure gauge should be very, very less. If suppose some mass is there, then it becomes a second order, because mass into acceleration. Acceleration is d square by dt square, means s square, there is a second order. Suppose the mass of the needle is very negligible. Suppose if you give a 1 unit step input, means 1 Newton per meter square or 1 bar pressure, the output is also showing 1. It is not showing 1.001 or 0.999. Okay, the meaning is like this. For a unit step input, to the first order system, the steady state error is 0. I introduced here the steady state error, but here the steady state, what is the limitation of this equation? Because here you need a output equation also. Because I know input, no issue. But I need a output equation also. That is a limitation. Okay. So if you don't know the output, means the entire transfer function is required. Output divided by input is called, the entire transfer function is required for this formula. Okay. So now the next type of input. Okay. So you have seen the response curve. Here no oscillations. No oscillations. Okay. Exponentially it is goes on increasing the output. The next output is what? Ramp input. The next output is called, next input is called ramp input. We will see in the next lecture. For ramp input, what is the response? Okay. So I hope you understood. Thank you.